right, we're in the final stretch here. We're going to talk about volume. We actually defined volume in a previous lesson, but I want to reiterate this. So we said that volume was the space inside of a 3D figure. And we knew this formula to calculate the volume of, say, a square prism, a cube, a rectangular prism, and that was the length times the width times the height. Okay, but in today's lesson, we're going to come up with a more general formula for finding volume of really any type of prism that we're given. Okay, so we're going to change this length times width times height into something that's a little bit more useful in a bunch of different scenarios. So let's go ahead and take a look at a few. Okay, so right now I'm trying to draw a rectangular prism. So try to draw along with me, please. Again, I always start with the two identical bases, okay, and make sure they're stacked on top of each other. And when you connect your corners, this is where things might get a little bit messy. So I would just connect the first three corners and skip this back corner here, so just because I don't want to get us confused with all the different lines and things that we're looking at. Okay. All right, and the dimensions of this rectangular prism, we have 5 here, we have 8 there, and 12 would be the height. Again, so actually I'm going to include a title here. So rectangular prism, we could also say cube, right? We know to use our formula, length times width times height, or you could just say multiply all three dimensions together. So let's go ahead and do that. We're going to do 5 times 8 times 12. 5 times 8 is 40. And then 40 times 12, well, 4 times 12 is 48, add a 0 on the end, so we're at a 480. Did I tell you our units? To get into the habit of this, I'm going to say that these are inches, okay? Again, not drawn to scale. So because we're talking about volume, remember, volume is always measured in cubic inches. So the volume of this rectangular prism we have here is 480 cubic inches. Let's take a look at another type of prism. All right, we're going to take a look at a triangular prism. So go ahead and draw the two bases, please. And then when you're connecting your corners, let's connect these two on the side. Well, actually, no. Triangular prisms are okay. Let's go ahead and connect all three corners to each other. There we go. All right, and the dimensions of this triangular prism, we're going to say that this side is 8 inches. I'm going to say this is 5 inches. And then this piece going across here, actually, let's say this is 12 inches. And there we have it. Okay, so I hope you're noticing a few things, because this triangular prism, hold on, let me write my title here. This triangular prism actually relates to this rectangular prism here, although it's a little bit difficult to draw this freehand. But notice how there are a lot of the same dimensions. Okay, now if you think about, well, how do triangles relate to rectangles? How are they related to one another? I'm not going to answer that, but hopefully you can come to the same conclusion. Our formula, length times width times height, no longer works here because our base has changed shape. So instead, we need to find a way to calculate the volume of this this new shape that we haven't found the volume of before. So I want to go back and quickly analyze how we found the volume of the rectangular prism. When you find when we calculated this right here, I want you to go back to when you first learned about area. What shapes can you use this length times width to find the area of? Did that make sense? What shape do you use length times width to find area, to find its area? Well, if you multiply length times width, you can definitely find the area of a rectangle. You can definitely find the area of a square. So again, remember, our goal here is to find a new way to find a new way to write how we find volume. In our rectangular prism here, this 5 would be our width, this 8 would be our length, and what this did, when we multiplied this together, we found the area of this piece here. And what do we call this bottom piece that just so happens to have an identical twin at the top? We found the area of the base. I'm going to write that down. We found the area of the base, and then we multiplied it by how tall the prism is, by the height of the prism. So in this case, with the triangular prism, let's go ahead and follow this new rule. Let's find the area of the base and multiply it by the height. To find the area of the triangle here, I need to multiply 8 times 5 and then divide it by 2. That's going to be the area of my base. So 40 divided by 2, that gives me 20. So 20 is the area of my base, and now I'm going to multiply it by the height of my prism, which is 12. So 20 times 12, well, 2 times 12 is 24, and then put a 0 on at the end, so that's 240 cubic inches. And look at that. This triangular prism's volume is exactly half of the rectangular prism's volume. Awesome. Let's take a look at one more example. All right, the last example we're going to take a look at is a hexagonal prism. So our two bases are going to be hexagons. So go ahead and try your best, draw two hexagons stacked on top of each other, and connect at least the front corners here. So I'm going to connect these first 4 corners. There we go. So now we have a lovely hexagonal prism. I'm going to say that this hexagonal prism has the same height of 12 inches, and then I'm going to say that the area of the base, so I'm going to write this underneath, area of the base is about 166 square inches. The reason why I give you the base of, or the area of this hexagon is because you guys won't need to find areas of hexagons until you're in high school. So let's pump the brakes a little bit, okay? So solving this problem, we have this new way of finding volume for other types of prisms, where we take the area of the base and we multiply it by the height. And that's really all we're going to do. If you have the area of the base, you can just multiply it, and you have the height, you can just multiply the two things together and you should get your volume. So we're given the volume, or excuse me, the area of the base here, which is 166. We know the height of this prism, so we're just going to multiply 166 times 12. So the volume of this prism is 1,992 cubic inches. And there you have it. So, in conclusion, we have a new way of finding volume for many different types of prisms. So, if you take away anything from this video, please let it be this. It is the area of your base multiplied by the height. You'll also see it written like this. V stands for volume. We have a capital B, which is the area of the base. And then, of course, times H, which is our height. Alrighty, folks, there you have it. There's volume.